Hello. In this presentation, I'm going to talk about C# exception handling. What is exception handling? Well, it's a mechanism for gracefully handling errors that occur at runtime. And the .NET Framework provides an object, system.exception, that is used to wrap information about such an error. And these errors can occur due to logic issues in our own programs, or they can occur for environmental reasons as well. So imagine we try to create a variable that's a reference, and then we try to do something to it before we allocate it using the new operator. Well, that's going to generate a null reference exception, right? So that's going to create an error condition and generate an exception object that represents the error state of our program. Now that kind of scenario is obviously caused by programmer error, but there are certainly lots of conditions that wouldn't be caused by programmer error. So imagine we've got a program that has to open a file of customer records and process it. Well, what if somebody else forgot to close the file previously and we can't open it? Or what if the file's not there? Those are problems that exist in the environment that the program's running in. They're not problems with the program itself. And we want to be able to respond to things like that gracefully and in such a way that the program doesn't straight up crash, right? Maybe it says, okay, unable to proceed, file not found, please notify so-and-so, or that the program will produce some sort of message that indicates how to proceed. Or maybe the program can actually respond to the error and try again in 5 minutes or something like that. So it's a way of what we want to do is build a framework where we can respond gracefully to errors that occur at runtime that are a result of the environment rather than problems in our program itself. So if you need to indicate that an error has occurred, you want to raise your own error message. You want to plant a flag in the ground that says, hey, everybody, look, something bad has happened. Then you use the word throw followed by new exception. So you can create your own exception object and throw it. And what you're doing is throwing it up the chain of command, hoping that somebody else knows how to handle it. And we'll talk about how to handle it in the future slides here. So what you want to do in your exception when you create it is supply a string that has as much information about the error message as you can possibly provide. Something like line 20 of file whatever, invalid customer record, and then include the customer record in the exception so that whoever gets the exception will have detailed information about what actually happened. The more information you can provide, the better. So just to throw your own or create your own error message, you just use throw new exception and then provide a message string. That's sort of the simplest case. Now, what happens if you're using somebody else's code, like the system libraries, and they raise an exception? How do you respond to that? Well, that's the purpose of a catch block. A catch block is where you respond to an exception that was thrown by somebody else. And if your program can't find any catch block to handle that exception, it'll just bomb out to the command line and print out the stack trace and tell you that an exception occurred and what exception it was. But what we're trying to do is prevent our program from crashing by implementing our own exception handling mechanisms. But if an exception is thrown and there's no catch block anywhere, your program will just straight up crash. Now, the more interesting case is what happens if you have function 1 calls function 2, calls function 3, calls function 4, calls function 5, and function 5 throws an error. It throws an exception. Well, what happens if function 5 doesn't have a catch block and function 4 doesn't have a catch block and function 3 doesn't have a catch block, but function 2 does have a catch block? Well, what happens is the .NET runtime will start unwinding the stack. It will start unwinding the system of call hierarchies that occurred, looking for a catch block that can handle that exception. And if it bubbles all the way back up to the top level and still can't find a catch block, then the program will crash out to the command line and print out information about the exception that occurred. But what we're trying to do is prevent that from occurring. So if you have if an exception is thrown what is called a stack unwinding starts occurring, where the program or the virtual machine, the runtime environment will start trying to find a corresponding catch block for that exception type. Now, catch blocks don't just operate on their own. They don't live on their own. They operate in conjunction with a try block. So try and catch go together in pairs. So here's an example of that. So we try some code that could throw an exception, and if you think that it could throw an exception, you want to respond to it, then you provide a catch block. So this is the most generic case right here, catch exception E, that will catch any type of exception. There are specific subtypes of exceptions, and I'm going to talk about that later, but this is your most generic, or this is your simplest try-catch kind of framework right here. So you would put the code that might throw an exception inside the try block, and if anything happens, you can respond to it in the corresponding catch block. So try, catch, go together in pairs. So if something blows up here, it will get handled here. And then your program will keep running merrily along. There are lots of different subtypes of exceptions built into the .NET libraries already. We've seen a lot of them, just through running past the end of an array or forgetting to use the new operator or something like that. So what happens if you wanted to catch different types of exceptions because you needed to handle them differently? Could you do that? And the answer is yes, absolutely you can. So you can have missing an S on the title there. But you can have multiple catch blocks. You can try, catch, 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 catch. You can have as many catch blocks as you need. So let's take a look at that. And then we also need to talk about which catch block is going to handle it. So only one catch block will catch the exception. It kind of works like an if else if kind of thing. And the catch blocks, the catch block that will handle the exception is the first one that matches the exception's type. So when you have your catch blocks, you have to put them in an appropriate order. You have to put them from most specific to least specific. So here's an example of multiple catch blocks. So try some code that could blow up, and I've got multiple catch blocks here, and notice I've got the specific type first, followed by the generic type last. So this is kind of like an else if statement, a whole bunch of else if statements with a dangling else with no condition. This just catches anything. So if I didn't catch the specific type of instruction or exception that I was looking for, just finally catch the generic exception, the base class of the exception type. Just catch anything. This is your backstop. This is your line of last defense here at the bottom, this catch. So if you're going to have multiple catches, you want them ordered from the most specific to least specific. So if you had inverted these, if you put the catch one first and an exception gets thrown, well, any type of exception is an exception. So then the catch block would, the first block that matches the type would handle it. So if you switch to these, the generic exception would handle it, and the index out of bounds exception would not handle it, because exception would match any type. Now, once you catch an exception, you may want to take some action and then rethrow the exception to somebody higher up the food chain. So think of this whole thing like a chain of command. Like, you're the private and you find a landmine in the road. Okay, well, what can you do? You can put a flag, in the road that says, okay, everybody, we got to stop. And then you tell the lieutenant, okay, hang on, sir, we've got some problems. And then the lieutenant maybe has to tell the captain up the food chain of command. So what we need to do is, and that's the purpose of rethrowing an exception. You can take an action and then still bubble the exception back up the food chain or up the hierarchy, so somebody higher up the command structure knows how to handle it. I mean, again, so like a machine on an assembly line catches on fire, the worker puts the uses the fire extinguisher, but then he's got to tell his shift supervisor, who maybe has to shut down the assembly line, who then has to tell the boss, who has to tell the truck that the stuff's not going to be ready, who has to tell the CEO to adjust the earnings report or something like that. So it's a way, this catch rethrow or catch throw is a way of handling an exception to the extent that you can, and then still throwing it back up the food chain for somebody at a higher level to handle. So, and here's an example of that. Now, so I've got function 2 and function 1. So function 2, all it does is just throw a new exception. It's never going to work. All it does is just bomb. And function 1 is going to call function 2. So if function 2 gets called, it throws an exception, and we catch it. So what we can do here is we could either take some action if we can, but when we rethrow this exception, we don't want to lose all of that information in the first exception that was handled. So if we just threw a new exception, that said function 1 failed, we would lose the error report for function 1. And that's why if you look at this constructor for the exception, you'll notice we've provided a second argument where we've actually supplied the original exception. So what we've done is, imagine you've got this call structure of catch and rethrowing several layers deep. You'll have an exception wrapped in an exception, wrapped in an exception, wrapped in an exception. So what you're doing is preserving the hierarchy of you're preserving all of the information all the way back up the food chain about the error message that occurred. So I would never just throw a new exception in response to one that was already that was already caught. If I'm going to rethrow an exception, I would add some error message information to it, but also preserve the original exception. So that's why this is important here. This type of constructor where we've provided the second parameter. So again, the whole idea of this is to create a new error message or a new exception that preserves the original exception that happened, and that way we're not kind of burying information somehow. Right? So if you want to report, send a report to your boss about an error that occurred, you want to staple to it the information that was given to you originally. That's kind of what you're doing. Imagine that these are error forms. You're stapling all the error forms together, so the boss at the top gets all of the forms stapled together from the bottom all the way up to the top. That's what this is doing. It's making a new exception that wraps an old exception so that no information is lost. Okay, now we're not done yet. There's another type of block that is used in conjunction with exception handling. It's very, very important, and that's the finally block. Finally blocks are optional. You don't have to have a finally block, but the advantage of the finally block, or the thing that's interesting about it or unique about it, is that it will execute even if the exception is even if an exception is thrown, or if no exception is thrown. So the finally block will always execute, and the purpose for that is to clean up or release resources that your program may need to get rid of. So it's a way of saying, I want to try to do this. If it blows up, I absolutely need to close my resources, and then I want to throw an exception, or I want to catch an exception. So let's take a look at finally block. So again, the purpose of the finally block is to make sure that resources are cleaned up. And here's the syntax for a finally block: try, catch, finally. Now you don't actually have to have the catch. You can just have try, finally, and we'll talk more about that later. So try to do something. If it blows up, then the finally block will run, followed by the catch. So if in my program, in my try block, I opened up some resources, but an exception got thrown, I could close those resources in the finally block and then catch the exception. So they would actually kind of jump around. It wouldn't kind of fall down. It would actually go from the try block to the finally block to the catch block. But the purpose of this finally block here is to close any resources that were allocated here in the try block. So try, catch, finally is just a way to make sure that your resources get closed. Now, C# does provide a shorthand version of this that I will talk about later, which is very commonly used, and you'll see it all over the place. So how do we make sure that resources get deallocated when they don't have destructors? Well, to jump ahead a little bit, or to kind of peek into information that we haven't covered yet, if a class or an object needs to get rid of resources, it has to release resources that it opened up at some point, it will provide a dispose function. It will, more technically, it will implement the iDisposable interface, which means that object has to provide a dispose function. And that dispose function will not get called automatically. You have to call it, explicitly to release anything that object may have allocated. You cannot rely on the garbage collector to call dispose for you. There is no guarantee the garbage collector will ever run. So you can't just say, oh, whatever, the garbage collector is going to come get my stuff. So if you're using some object like a file or a stream that implements the iDisposable interface, meaning it has a dispose function, you should make sure to call the dispose function in the finally block. Now, what if you forget to call the dispose function in the finally block? Well, there's a mechanism in the language to kind of prevent you from forgetting to call the dispose function. And as I said before, you don't actually need the catch block, but here's an example of calling the dispose function in a finally block. So imagine that thing T allocates some resource that needs to be cleaned up. We need to make sure that whether or not an exception occurs, we need to call things dispose function to close whatever resource. So try finally is a very commonly used frame or kind of syntactic device for making sure that objects have their dispose function called when you're done using them. So, as I mentioned before, since try finally is so important to make sure that resources get released, there's a shorthand version of try finally, and that is using. Using is syntactically equivalent to try finally. So let's take a look at two examples here. So here's the previous example on the left. Thing T equals new thing, and then try to do something with T, and then even if it blows up, make sure its dispose function gets called. And let's look at how we could, but there's always the possibility we would forget to call the dispose function. What C# provides is this using statement on the right, which is a short form of this, what you see here on the left. So using thing T equals new thing, this is syntactically equivalent to, or this is functionally equivalent to what you see on the left. So what's going to happen here is at the end of this using statement, thing T's dispose function will get called. So if you need to make sure that something's dispose function gets called, just use the using statement. You see this all the time, particularly with like any sort of thing that's operating on streams, because you want to make sure you close the stream if you're reading or writing to a file. So otherwise no one else will be able to read or write to the file. So using is a syntactic shorthand for what you see here on the left. And you'll see using all over the place. Using is just a short form of try finally. This seems to be a standard interview question, so know what a using statement is for. And so know that it is an equivalent for try finally, and it is supposed to make sure that that resources, that any object who implements the iDisposable interface has its dispose function called. So just general kind of thoughts about exception handling. Don't bury an exception. Never have a catch block that just doesn't do anything, that just like swallows up the exception but doesn't handle it. It doesn't provide any information that the exception actually occurred. You don't want to kind of use them in place of just regular coding correctly. Like you don't want to just have a try catch block around anything that uses an array just to make sure, just in case you go outside the edge of the array. You want to make sure that you're always adhering to your array boundaries. If you can't handle the exception, but you caught it, like if you catch an exception, but the layer of the program that you're operating at really can't do anything, that's when you would log an error message and then throw it back up the chain of command for somebody else to deal with. Remember, this is that example of the machine catches on fire, so the line worker puts out the fire, but then he's got to tell the shift supervisor who shuts down the assembly line, who's got to tell the CEO, who's got to adjust the earnings report, or something like that, right? You're trying to, every layer of the program is trying to take whatever action it can, and particularly logging, and then throw the error message up the chain of command to the very top level. So you see this in Unity, or I see this in a lot of programs. The program will crash, and you can tell that an exception occurred, and at the very top level of the program, what does it do? What does that last catch block do? It brings up the crash reporter, which just takes all that information, puts it in a window, and says, would you like to submit this to Adobe or Unity or Autodesk or whatever? And then you click send. That's the final catch block at the top of their application, is the crash reporter. Make sure that when you're catching exceptions and rethrowing them, don't lose any information. So make sure if you're catching and rethrowing, make sure you use that constructor for an exception that not only provides a new error information about the error, but the original exception as well. So you're taking exceptions and wrapping new exceptions over top of them, so that whoever gets the finally can handle the information, has the full full kind of chain of command, the full stack of error messages when the error message actually gets handled. So right, it's not very useful for the crash reporter to just report, well, the application crashed or error on line 5, right? What you want is unable to parse, this OBX file, error on line 5, invalid syntax, and then what was what under what circumstances was that trying to happen, and what was the context for that happening, and what was the context for that happening. You want to preserve as much information about the error, the chain of command. What was the program trying to do when it actually hit an error, when it hit this condition? And that's going to make debugging it much easier. It's error on line 25 doesn't help you, but if you knew what the program was doing when it was what happened, what got it to line 25, that would be helpful. And I wouldn't say line 25, but what happened when it got the file not found exception? What was it actually trying to do? You want a full kind of hierarchy, or full stack of error messages. Log everything everywhere, right to the console, right to a file. The more information you can save or preserve, the better. And when you write all this stuff, the bottom one is the most important thing. Imagine that you're the poor guy whose phone rings at 2 a.m. saying, "Hey, this server crashed, and we don't know why, but it's mission critical, and we've got to figure it out." And you open the thing up and it just says null pointer exception. That doesn't help you. You want to get null pointer exception in the name of the function where it happened, and then what function called that, and what function called that, and what function called that, and what was the whole program trying to do. The more information you can get in that error log, or in that dialogue, that message box that pops up, or the better, the more useful it is, and the faster you're going to be able to fix your problem, which is the whole purpose of the exception handling in the first place, right? We're trying to write programs that are bulletproof, that can handle errors that occur due to the environment, and then if they can't, produce a crash report that someone can use to fix the problem, and so it doesn't happen again. So those are my thoughts on exception handling. Just think of it like the chain of command, right? At the lowest level, you want to take whatever action you can, report it, and then report it to the next guy up the chain of command. So the guy at the very top level can make a sensible decision about whether the application can proceed or not, or proceeds in a different direction, or just quits. So that's what we're trying to do here. Just really think of exception handling as part of a chain of command that's designed to make your program more flexible and more robust. So I hope that was useful. In the next video I'm going to make here, I'll actually write some programs that implement all this stuff so you can see it in practice. So, and as always, if you have any questions, just email me. I'd be happy to help you.